Hello and welcome to the mole unit crash course. This crash course is great for if you've just learned about the mole and learned about molar mass, moles to grams, and using Avogadro's number. This crash course is by the one and only Wall-E, or Miss Waldron. The questions that will be covered in this crash course are these 10 questions right here. So you can refer to this page or anything. What you'll need is, if you look to the right, you will need paper. Use your pause button. It's your friend. Pause. I'm going to go fast. I am only doing this as a refresher, not as a learning. So pause, rewind, and watch again if you need some help. I can't learn this for you, so just watching the video will not make you learn the whole mole unit. You have to do it. Pause it. Try to solve for the problem before I go over the entire problem. Then you can play it to see if you got it right, and if you got it wrong, then you can rewatch that part. All right? Use this as a tool so you can learn. Let's get down to it. All right, let's look at the first two questions. It's all about molar mass. Whenever it wants a molar mass, you got to look at your periodic table. So grab one. And as you can hear, I'm trying to grab mine. Whoosh! And I have to add up the masses of what's seen. The subscripts multiply how many atoms you have. So remember, when you're calculating this, it's just what atom do you have? Hydrogen. What's its mass? 1. How many are there? 2. So 1 times 2. Plus whatever sulfur is. So sulfur, how many are there? 1. 1 times the mass of, or we'll do the mass of sulfur first. There's 28 times, there's only one of them. It doesn't matter what order you have those two, but you have to multiply them together and then add the two together. So like this one, so 1 times 2 plus 28 times 1, I get 30. 30 is the molar mass. The unit for molar mass is grams per mole. You have to have that unit if you're calculating a molar mass. It's always grams per mole. Make sure you make a note of that. It's always grams per mole, not just grams. All right, so let's look at the molar mass of our second compound, Al2SO4 3. This one has parentheses. Okay, what does that mean? I'm going to use different colors to help us out. Let's look at aluminum. Aluminum's mass is 27. So I'm like 27. That's the mass of aluminum. I'm going to show my work a little bit more with this. Then I'm going to multiply that by 2 because there's 2 of them. All right. And then I'll add the mass of sulfur. And I'm like, okay, sulfur. It's 32. Oops. Sulfur is 32. Times however many sulfurs there are. Since the sulfur is in parentheses, there's only 1 right now. But I have to look at the 3 that's outside the parentheses. It multiplies everything inside, just like math class. So there's 3 sulfurs. Plus, now I have to look at my oxygens. My oxygens, there are 4 of them. But again, that 3 multiplies with 4. So oxygen, I look on my periodic table, is 16 times 4 times 3 is 12. So 16 times 12. And that is how I get my entire molar mass. So if I put that in my calculator, oh no, I just erased all my stuff. Good job, me. 1 second. I'm going to pause. Now I have it back. Sorry if the change of color throws you. All right, so when I put that all in my calculator, that's why calculators are your friends. I put that all in. I get 342. And again, since this is a molar mass, it's grams per mole, or G over MOL. Okay? All right. So now let's look at simple conversions using grams and moles, since we're just talking about it. All right, so using how molar mass is grams per mole, right? So like beryllium, if I want to look at that molar mass, beryllium is 9 grams per mole. I can rewrite this as 1 mole is equal to 9 grams of beryllium. So using this will help us make our conversion charts. How to make a conversion chart as a review. Read the question. So like number 3, how many moles are there in 25 grams of beryllium? I'm going to erase all this stuff right now. I need to underline what's given. So I have 25 grams of beryllium. Then you want to circle what you're trying to solve. We're trying to solve for moles. So that'll help us with our setup. So 25 grams, that goes in our top left. So 25 grams of Be. And I make my setup. Whatever I underline goes in the top left every time. Nothing's going to go underneath. I want to convert grams, so I don't want grams anymore. So the G travels down to the next one. It always travels down. So goodbye, G, go down. So I can cancel you out. Then, since we just said grams are related to moles, 1 mole goes on top. And then so the molar mass of whatever beryllium is goes on bottom, which is about 9. So I have 25, 1 mole over 9. That's that equal. 1 mole equals 9 grams. All I did was rewrite it into here. Huh, isn't that cool? So, how to solve. I make sure my units canceled, so grams are over grams, they're gone. Now put in my calculator, you put the first number in, 25. Open a parenthesis when we see a vertical line, then top, which is 1, divided by 9. Because if you see a horizontal line, that's a divide sign. So when I have this in my calculator, I should have 25, open, 1, then the divide sign, and then 9. And I get 2.7777. Let's just say 2.8. And what unit we have is whatever's left over. Notice, whatever's in my top right is also the thing I circled. So they should match. And that way I know my answer should be moles. Perfect. So let's do the same thing again, but with a compound. All right, same thing. Read the text. How many moles are there in 220 grams of Na2Se? So I underline the 220 grams of Na2Se. I circle moles. Whatever I underline goes in the top left. So 220 gram of Na2Se. Make my X's. I make sound effects for mine. And then I'm like, okay, grams. Take them down. Take them down, cancel them out. Grams are related to moles, so 1 mole goes on top. All right, so now to set it up, I need the molar mass of Na2Se. And I get about 125 when I figure out the molar mass, and that's from before. So I'm like, okay, let me check my table. Grams are gone. All right, you have to have one on top of the other in order to cancel them out like that. Then, whatever I circled, is it in the top right now? Yes, it is. Perfect. So now I'm done. I'm going to put this in my calculator. So 220, open a parenthesis, 1 divided by 125. Close it, enter. And I get about 1.76. So how about 1.8 mole? That's my answer. So that's how you convert grams into moles. Now let's go the reverse, moles into grams. All right, so once again, we're using the equality that 1 mole can be equal to grams when we look up the molar mass. Okay, it's always about that molar mass. Okay, whenever you need grams, it's molar mass. So let's look at the question. How many grams are there in 5 moles of silicon? So I underline 5 moles of silicon. Circle grams. Whatever I underline goes on the top left. Doesn't matter if it's moles, grams, donuts, whatever. Silicon is about SI. Make my chart. Nothing underneath. All right, so same thing. Notice, want to get rid of moles. Bring it down. So now the mole's down here. So 1 mole's going to go down here, and grams will go on top. So I need the mass of silicone, which is about 28. So I put that in my calculator. So 5, open a parenthesis, 28 divided by 1. And press enter, and I get 140. What are my units? Well, the moles are gone. Grams is the only thing left, so it's grams. Okay, that's my final answer. You must have units. Units are your friends. It helps you make sure you got the right answer. All right, next question, but with the compound, just like before. Mark our text. How many grams are there in 0.25 moles of CH4? I want to solve for grams. So whatever I underline goes in the top left. 0.25 mole of CH4. Make my chart. And then bring down those moles. Goodbye moles. Bring them down. And then grams will go on top. For every 1 mole, what is the mass of CH4? It's 16 grams. Because I've just figured out the molar mass of that. So I'm like, all right, moles, brought them down. Cancel out those moles. Because they're gone now. One's over the other. Grams is the only thing left. That's what I circled. I'm done. So now I'm just going to put in my calculator. 0.25 times, open parenthesis, 16 over 1. And what do I get? An exact 4. Ooh, pretty. I'm just going to be more accurate and said it's 4.0. 4.0 grams, or 4. That's fine. Boom, 4 grams. Dan, dan, dan. Done and done. Now we know how to master mole to grams and grams to mole using molar mass. Da, da. But now, big numbers. Warning, warning, big numbers are ahead because of lovely Avogadro. Because you got to get some Avogadro or avocados to make some guacamole. I know I'm a dork. Anyway, talking about Avogadro's number. Let's see. 1 mole of anything, doesn't matter if it's water, donuts, whatever, is equal to 6.02 times 10 to the 23, whatever you want. But most of the time, we're going to talk about atoms or molecules. It doesn't matter which one, we're going to use the same number. All right, so 1 mole equals that amount. So that means we can get rid of moles or we can get rid of atoms and molecules using this. We're going to still do the same thing we've been doing. Mark our text. Calculate the number of moles in 9.13 times 10 to the 24 atoms of magnesium. That's what we're given. And we want to calculate moles. I know that's a huge number and it's scary, but it's just a number. It's okay. We're going to do the same thing we've been doing. All right, I underlined. That means that goes in the top left. 9.13 times 10 to the 24 atoms. All right. Now, just like before, atoms, bring them down, bring them down. So I'm like, okay, atoms, I'm bringing you down. And then I'm like, wait, okay, atoms are related to 1 mole. So 1 mole goes on top. And whatever goes on the bottom is the other side of the equal sign. So Avogadro's number. So 6.02 times 10 to the 23. That's the number. Now, the atoms are gone because one's on top of the other. Moles is what's left. That's what I circled. Now it's just putting in our calculator. How to put in the calculator. I'm going to write all of my calculator stuff out down here. In my calculator, I put the first number, 9.13. Now for times 10 to the 24, do not use the caret. You need the capital E. How to get the E? Press the second button, plus use the comma button. That's right above the 7. You'll get that capital E. Then put 24, whatever the power is. So the power is to the 24, so I'm saying E24. That's telling the calculator this times 10 part. Okay, so always use that E. Then just like before, I open a parenthesis, top number, which is 1, divided by the bottom number, Avogadro. So 6.02 E23. Close. And now I just press enter. And when I put that all in my calculator, I get the answer of 15.16. So 15.2, what's my unit? The thing that I didn't cross out, moles, and what I circled in my question, because that's what I'm trying to solve for. Ta-da! All right, so now let's say we start with moles and we want molecules or atoms. Let's look at question number 8. Question 8. Let's mark the text. All right, how many molecules of BO are there in 0.100 moles of BO? I'm sorry, I'm a kid. BO, body odor. This is a stinky problem. I know. That was such a fake laugh. Anyway. All right, so I have that. I circle what I'm trying to solve for. I'm trying to solve for molecules. All right, whatever I underline, I'm just going to put it right away. 0.100. I'm going to write a little bit smaller. 0.100 mole BO. Stinky problem. Nothing underneath. Take a mole, bring it down. Mole, down. Perfect, 1 mole. Trying to get to molecules, so I'm going to use Avogadro's number. 6.02 times 10 to the 23. These are molecs. Okay, then I just see, did I cancel everything that I was supposed to cancel? Mole over mole, good. Molec, yes. Boom! Now I'm going to put this in my calculator. So 0.1, open parenthesis, 6.02, e to the 23 over 1, close, enter. And I get, I'm going to write this down here, 6.02 times 10 to the 22. And these are molecules. If you're ever solving for molecules, you should have a times 10. There's a lot of them. Remember, 1 mole is a ton. So we got to make sure our answer has that times 10. Or you're off by like billions and mega billions or sextillion, right? I think that was the name for that giant number. Sextillion. All right? That's how far off you are. A lot. Don't be that far off with your answer. Okay? So now we looked at the 2 different equalities. Now let's combine them into one. We're going to go both ways. So 2 more problems. Then we are ready for mole retake or the mole test or whatever you're trying to study for. That's just using moles, Avogadro's number, and grams. All right, looking at question 9, we know 2 different equalities now. That 1 mole can equal to mass, grams, if we look at the molar mass. And we know how 1 mole can equal Avogadro's number of things, like atoms or molecules. Okay? So using those, we can use them in our conversion chart. So don't focus on how big it is or whatever. You're still just going to underline and cancel. So let's do it. Just do it. Let's read. How many grams are in 6.485 times 10 to the 23 atoms of copper? Underline what's given. Circle where we want to go. Grams. Take it one step at a time. All right. 6.85 times 10 to the 23 atoms of Cu for copper. Make my chart. I don't want atoms anymore, so atoms, go down. So I'm like, okay, atoms, you're down here. And then what are atoms related to? 1 mole. You can only do that. Atoms are only related to moles. So the equal, whatever they equal, the other thing has to go on top. Notice that happens every time. So 1 mole is equal to 6.02 times 10 to the 23 atoms. And I'm like, all right. So atoms are gone. Goodbye, atoms. And now I'm to moles. Sweet. What did I circle? Grams. Dang it. So that means I have to add another step. That's all that means. You're not done. So then I'm like, okay, mole, I'm going to bring you down. Bring it down. All right, mole, you're down here now because I don't want you anymore. I thought I did. I lied. So per every 1 mole, I can get to grams by looking at the other equality on the left. So then I'm like, okay, copper, how much do you weigh? You're not supposed to ask a woman for its weight, but copper's just an element. All right, so 63.5. 63.5. And I go, all right, so moles, you're finally gone. I'm 2 grams. That's my top right. There we go. And yeah, this is a 3 setup, but that's just because I just needed it. All right, so now we're going to put this all in our calculator. Same thing as before. First number, 6.85, E, 23, open parenthesis, 1 divided by 6.02, E, 23, close parenthesis, open another parenthesis, 63.5 divided by 1, because top divided by bottom, close, enter. Got my answer, 72.3 grams. Boom, because that's the only thing that's left. Yes! Take one step at a time. You'll notice if you're solving for grams, you won't have times 10 or anything. It shouldn't be gigantic unless you had like a ton of atoms. But a lot of times you won't have a times 10 in your answers if you're solving for grams. Okay? All right. Last one. So how about if we start with grams and we want to solve for atoms or molecules? And this will be the last one, and we should be a master at this. Okay, so I rewrote my equalities, so it helps with my conversions. And I go, all right, read the question. How many molecules are in 2.8 grams of H2S? I have no idea. Let's find out. So 2.8 grams of H2S. That's what starts, and I'm going to molecules. So start 2.8 grams H2S. Make my chart. Goodbye grams, we don't want you, or I wouldn't be doing this. So grams goes down. Grams are related to what? Moles. So 1 mole has to go on top every time. Now forget the number of grams, you got to look at what you're talking about. So it's H2S. So if I look, sulfur is 32, each hydrogen is 1, so that's 34. 34 grams per 1 mole. So my grams are canceled. Goodbye grams. Now I'm at moles. What did I circle in my question? Molecules. Not there yet. So got to get rid of those moles. So bring down those moles. So I'm like, okay, moles, bringing you down because I don't need you anymore. So per every 1 mole, there's Avogadro's number, 6.02 times 10 to the 23. Since I'm doing molecules, it's molecs. Molic. So my answer should be big. So moles are gone. Molic is what's left. That's what I circled. Yes. Dun, dun. Now to put it all in our calculator. Let's do it. Let's see. I need 2.8, open parenthesis, 1. 1 divided by 34. Do you hear my clicking? Click, 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 click. Close, open. 6.02, E23 divided by 1. Close. And I get, you got to look at the entire calculator because it says 4.957647059 E22. Make sure if there's an E on there because we're solving for molecules. There should be a lot. So let's round it. So 4.96, look for the E, times 10, E22. And then our unit left is molecules. So this is molecules. Molic. Ta-da! That's our final answer. You made it this far. Here's a joke. Just because I have to. Why did Snoop Dogg need an umbrella? Faux drizzle. Ah! Yeah. All right, so that's 10 questions that'll help you for any mole unit test, review, crash course. I didn't learn it the first time. I hope you paused me. Hope you rewind. I hope you rewatch this, learned, did a bunch of things on your paper. You got this. I believe in you. Whoever you are, I believe in you. You can only do your own learning. I can't do it for you. I wish I could. Okay? I can't just shove that information into your brains. All right? Good luck. You're awesome. You can do it. You do it. You do it. You can 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 do it. Yes!